Today we're talking about absolute value functions, which for some of you may be completely new, but what we are used to is quadratic functions. We have graphed parabolas before, and absolute value functions are going to be very similar in how they behave and how we transform them. So let's start with what an absolute value function is. Now, we know from basic algebra that the absolute value of 2 is 2, and the absolute value of negative 2 is 2. So basically the absolute value is going to make things positive. Well, what about when we take the absolute value of x? Well, the outcome is going to depend on what x is. When x goes in as positive, then x just stays the same. So it's equal to x if x is greater than 0. It's also equal to x if x is equal to 0, because the absolute value of 0 is 0. But if x were negative, then we would have to take the opposite of x. So if x is less than 0, we take the opposite of x. Now, what this does as a graph is very interesting. Let's start with a basic function, y equals the absolute value of x. Now, again, when our input is 0, our output is 0, because the absolute value of 0 is 0. And when the input is a positive number, the output is a positive number, because the absolute value of a positive number is positive. And so on this side of the function, we get something that looks very similar to the lines that we've been graphing before. Just like this. The only problem is it can't extend down into the negative region down here because we can't get negative outputs from our absolute value function. If I were to plug in -1 for x, I'd get out +1. -2 would give me +2. -3 would give me +3. And so what I get is a reflection of that section of the line shooting off in this direction. Now, here's what I want you to notice. What is the slope of this side of the line? 1. What's the slope over here? -1. And that's always going to be the case. The slopes are going to be opposites. Now, this point here, just like the lowest point on a parabola, is called the vertex. And normally we're going to refer to that as HK. So hang on to that because we're going to use that a little bit later. But I want to introduce you to the basic form of an absolute value function. And it's going to look it's going to look very similar to the basic form of a quadratic function, especially as we get moving on. It looks like this. Now, each one of those letters, the A, H, and K, means something different for our graph. HK is our vertex. H represents a horizontal translation of our function. And K represents a vertical translation of the function. So H slides it side to side, K up and down. And notice that it's opposite. So if this were x -3, we'd be going to the right. And if it was a +7 on the outside, we'd be going up. But if it was x +2 on the inside, we'd go into the left. And a -7 on the outside would take us down. The A is our compression or stretch factor. And basically, it's going to become our slope, positive or negative. Now, if A is positive, we have the type of graph we just saw, a V. It opens up. If A is negative, we have more like an A-frame. It opens down. It's that reflection that we're used to. So let's try the first example. Example 1 asks us to graph y equals the absolute value of x + 4 minus 2. So the first thing we need to do is locate our vertex. Where will our vertex be? -4, -2. Remember, we take the opposite of this number here because it's a leftward shift, but we take this number directly, so downward. And what will be the slope of our lines? 1 and -1, because we have no different a out here to change that. And since if there were an a, it'd be positive, that's just an invisible +1, we're opening up like a V. So all I need to do is put enough points on here to dictate that slope of 1 on this side and the slope of -1 on this side. Then I can draw my V. There's my function. That's all there is to it. Now, if I change a, the graph changes quite a bit. For instance, y equals 1/2 times the absolute value of x. Now notice that my h and k are 0. They're not even there. And so my vertex is still at the origin. What's my slope going to be? Right, 1/2. It's from that a right there. So all we need to do is go up 1 and over 2. Rise of 1, run of 2. So we have a slope of 1/2 in this direction and a slope of -1/2 in the other direction. And then we can play connect the dots. Now this is what we call a vertical compression of y equals absolute value of x, because the absolute value of x would be up here. That 1/2 is basically squeezing our original function down, so it's a compression vertically of the original graph. Now let's graph another one. Y equals -3 times the absolute value of x. Again, our vertex is at the origin, but what's our slope this time? 3 and -3. And since it's negative, instead of being a V, it's going to open down like an A-frame. So we got a rise of 3, run of 1, -3 as we go to the right, +3 as we go to the left. So we got this A effect going on. So this is both a vertical stretch, because notice it's getting skinnier like somebody's pulled on it, and a reflection because it's been shifted upside down. All right, the last example we're going to go through today combines the stretch and the reflection into one problem. And so I'm going to do one, and then I'm going to give you one to try, and we'll walk through it after you've had a chance to do it on your own. So -2 times the absolute value of x minus 1 plus 3. First of all, where's our vertex? 1, 3, right here. Now, is this going to be a V or an A? Well, since this number is negative, it's going to be an A. And what's our slopes going to be? 2 and -2. So I plot those down 2, over 1 in one direction, over 1 in the other direction. And I can make a couple of points if it helps me guide my arrows. So all I have to do now is play connect the dots with my rays. There's my function. And that is both a translation, 1 unit to the right and 3 units up, and a vertical stretch. Now, if you notice, whenever a was greater than 1, or the absolute value of a was greater than 1, because in this case it's negative, but it's still a number bigger than 1, we have a stretch. But when a was 1/2, that is the absolute value of a is less than 1, we have a compression. It got a little flatter. Okay, so that'll help you if you have to describe the transformation that we're seeing. So I'm going to give you one to try on yourself. I'll give you the equation, and then we'll pause the video, give you a chance to work through it, then we'll unpause the video and work through it together to make sure that you've got what you're looking at. So the first thing we need to do is establish our vertex, which, because we have an x plus 1, tells me I'm starting at x equals -1, and we have a -2 outside, which tells me I'm starting at -1, -2 right there. My slope comes from this -3. Since it's negative, I know I'm opening down, and I've got a rise of 3, run of 1. Let's clean that up a little bit. Rise of 3, run of 1, rise of 3, run of 1, and so on. Oops. And all I have to do Let's draw my arrows. And that's all it takes. Now, if you have any questions, feel free to ask. You can go back and watch the video if you need to see it again, or if you're all set, you can move on to your homework.